Okay, hopefully I'm going live. We shall see. And we'll make sure that hopefully that's not going to turn live. We'll see. I might get an echo if it goes live. Hi all. Hopefully you can see me, you can hear me. If you can see me and hear me and it sounds good, let me know. Okay, that's not going good. I always have to worry about Patreon. I try to monitor what's going on in Patreon and it turns everything live. So let me know if you hear an echo. You shouldn't hear an echo. Everything should be good. I see hi, 5x9. Excellent. Thank you, Roger. I appreciate that. I see Tim. I see Jennifer. I see Steffi. I see Mike Richardson. Thank you so much. Mike, you are, everybody be very nice to Mike. He is one of the moderators and he will boot you if you are not behaving yourself. And I appreciate it, Mike. And Jerry Ryan is also here. Both of these gentlemen will take good care of you if you have questions that I do not see. As you can see it moving up in the chat here. If there are questions that I do not see, they will promote them for you. So keep asking them. If I pass over them accidentally, I will, I just do the best I can. And also thank you guys for being up so late. I know it's kind of late in the day. I am going to, let me switch one thing to make sure that it is on top. Okay. There we go. I want to make sure my camera's on top, so if I point to something in the chat, you guys can see what I'm pointing to. Okay, so again, thank you for being on. It looks like you guys can hear me and see me, and this is wonderful. I will say hello to everybody as we go on, but I see tons of you guys in here. You can see yourselves in the chat, so yes, I am seeing you too. I am going to get right to it because I know it's really late for a lot of people, and for those of you who are over in the pond or on the East Coast, I know you want to go to bed. And you may have been waiting for this since, early, sometime almost 6 hours ago or something when I first said I was going to go live. This has been an incredibly difficult set of solar storms to deal with. The fact that we had a G3 level really tells me that we have a big issue when it comes to solar storms. It was what we call stealthy solar storms. At one point, we thought that these solar storms were the kinds of storms that would only be launched right around solar minimum or near solar minimum when the sun was reasonably quiet, and the only types of things that lift off the sun are very passive structures. And that during solar maximum or near solar maximum, these structures might go away simply because there were so many other eruptive structures that basically these stealthy solar storms didn't have time to form. But it does look like we do have them along with everything else, at least during this solar maximum. And they are what we call problem geomagnetic storms here at Earth. And so that's what we are experiencing now. So I will do my best. You will see the pain that we space weather forecasters go through. I have been talking behind the scenes with people from the NASA, multiple forecasting agencies at NASA, also the 557th. And yes, these things are very painful to catch, and we don't always do as good a job as we'd like. So, okay. Looks like everybody's here. Looks like everybody can see me. I'm going to drop the chat so we can get started and I can give you the BLUF, the bottom line up front. Okay? So give me one sec while I switch. All right, trust me, I can still see your chat. I'm just not on the screen. Okay. All right, so this has been intense, and forgive me if I don't remember all of the sunspot numbers. I've numbered everything, but I'm literally going to be going through this this chart deck or this deck here pretty much the first time along with you. So as I can get this thing moving, yes, I did put everything together. As you can see, we've got lots of different stuff going on in the disk. This is a composite image that has things that you can see like coronal holes. You can see a few coronal holes in here. We are going to be getting some fast solar wind here over the next few days. And along with everything else that we're getting. And so that makes things a bit tougher, but I will pause and back up and try to show you everything. The biggest region to watch, at least over this past week, has been region 3654. As you notice, it'll start getting really clustery. There's lots of other regions in through here. But this region has been, as you can see, it's not that far from a coronal hole. And that's always a problem for us because we have filament channels in these regions in here. And these filament channels, and as you can see, there's lots of filaments everywhere. Filaments are like a lot of the snake-like structures you see. We have tons of them. We've also been watching this one. As you'll see, it almost looks like it wants to erupt, but it probably won't. But anyway, having these filaments and having so many of them makes it very, very difficult for us to keep an eye on everything. And because a lot of these bits and pieces are flying off the sun constantly. We are literally in the solar maximum phase, so we are averaging about 8 coronal mass ejections a day. That means 8 solar storms a day. Doesn't mean 8 hit us, but you can imagine for a space weather forecaster how difficult that is to see one and discern one from the other when all you've got is a coronagraph, which is kind of like a flat plane in the sky. So all of these different things leaping off of the sun nearly simultaneously, and they're all overlapping. They have a tendency to camouflage one another, and you'll see a lot of that here. Okay, so if we keep our eye on region 3654, it's the one that's been flaring a lot. You'll see a bunch of flares coming through with this region. But believe it or not, if I back up already, because I started it out, right on the 27th is when I'm going to be starting, because this is one of the solar storms that hit us just over the last 48 hours. Let me just double check to make sure no one is contacting me for any particular reason that something's gone wrong. No. Okay. Right on the 27th, or reasonably early on the 27th, you will not see this, but there was a stealthy solar storm that launched, and I'll show you right about there. Did you see anything? No, I wouldn't expect you to. In the coronagraphs, we really didn't see much on the disk unless you do special imagery, and I'll show you what that special imagery is in the deep dive, but right now I want to get through the BLUF. What you're looking at is the coronagraphs for this period. You can see lots of stuff leaping off the limbs of the sun, but that's not the big point. The big point is this structure here that you see, and you'll see another kind of one down here. I'll show arrows as this thing goes out. You see the arrows right there? Let me back up again. So if you can see this light structure here and this light structure, and I have yellow arrows. I don't know if you can see those yellow arrows very well. I should have chosen a different color. But this was the halo. Okay, you don't see much of it here. You don't see much of it here. It's kind of camouflaged a bit. But this was the little sneaky bugger that nobody caught. I was working on other things, sadly, so I didn't end up getting eyes on this. And I posted this in a forum along with some NASA folks. And they were like, ooh, sneaky little bugger, we didn't see this. And so it's like, okay, well, I think that structure is going to be coming to hit us. And as a matter of fact, on my Patreon page, I even talked about this particular structure. And sure enough, it did hit us. The thing is I'll tell you later, this one, which hit us just like yesterday, this one was actually mostly northward field. So we really didn't get much of it. I think we got to active conditions and then things kind of died down. Had it been the opposite way, which we'll talk about in the deep dive, this could have been a G2 level storm. But because of the orientation it was actually more like a bumper car. So we kind of skated through with this one. So as that goes away, now we keep following the same region, and again, it's firing. You start noticing little solar flares from here. We've been getting mostly low R1 radio blackouts, a couple R2s, almost an R3 at one point, but they've been really what we call impulsive, very fast solar flares, not really bothering us all that much, and really not looking like they're launching any big solar storms at Earth. That didn't start. The big solar storms didn't start launching until this region kind of rotated closer to the west limb. So on the 29th, we get yet another incredible launch that is very difficult to see. Hold on, here's the 29th. It happens right about in here. There's some activity going on in here, some activity up in here. Really hard to see, guys. Really hard to see unless, again, see anything? Not really. Unless you had special techniques that you're using. So this was yet another stealthy solar storm. And here's the thing, and this is the one that's hitting us now. Here's the thing with this structure. There is so much other junk coming off of the limb. Again, I will show you more of that stuff in the deep dive, that the coronagraphs are a mess. Look at all this jaggedy junk. Blah, 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 blah. Believe it or not, there is a halo in here, a partial halo. Now, is the solar storm that's hitting us now this halo? From this halo, or is it from this next one? I think it's the one I just showed you. But let me show you something else. Just a few hours later, literally at the same time that we're watching this, where this image of the sun is frozen, watch this other set. You've got 2 more solar storms being launched on the limb. Once again, makes it really hard to see something that's coming toward Earth. But if I forward this right about halfway through, and I'm trying to kind of see if I can see this very well, there you'll actually see a little bit of a curl right here. I think I actually stop it. Whoop, hang on. Back up, back up. Do you see this right here? And if I go back just a little bit, do you see this thing kind of caught in here? This, I do believe, may be yet another solar storm that is headed toward Earth. And I'll tell you why as we get to the end of this. So we may yet have one more stealthy solar storm trapped in all of this junk that ends up giving us issues from this same region or near region. It's not really region 3654 that's launching them. It's in this region in here close to what was kind of a solar, kind of a coronal hole that's like, you can't really see it very well in this composite, but there's a filament channel and all sorts of weird stuff going on. So I'll show you that, and I'll tell you why I see that. You'll see it too when I start showing you some of the more deep dive stuff where I'm looking at the sun using a different technique, okay? All right. Now, since then, okay, so now we're going to be moving on to stuff that's going to be up and coming. This region is now rotating to the west limb. Yes, it's still a big flare player. Yes, we still could get chances for big solar flares from it. We do even have one more big solar storm launch, but I do think that one's going to miss us. That was far too close to the limb. You'll see it here in a sec. But the big region to watch now is region, I believe it's region 3663. Let me see here, it's at 3662. It's one of the ones that's growing super fast, and it's beginning to fire off big solar flares now, or it's about to, because it's growing quite quickly. It's now an X-flare player. So this region here in this kind of cluster of regions where we're kind of got a risk for radiation storms right now, so we're paying very close attention to them. But over the next couple days, they're going to disappear, which is going to drop the chances for radio blackouts just a little bit. But we've got some hot regions over here that are in the north that are taking over. Okay, so we've definitely got to pay attention to that. And let's see. Is there anything else I want to show? Also, here's some coronal holes. We're going to get some fast solar wind from these regions here, probably around the 5th. So we're going to have to pay attention to that. And we are still watching quite a few filaments. This one is the one I'm really concerned that it might erupt, but it doesn't look like it. It just looks like it keeps sloughing off in pieces, and that kind of relieves the stress. So lots of stuff, as you can see, on the sun. We definitely are in the solar maximum phase, yes, and it's region 3663. Did you see that thing fire right there? I'll back up a little bit. So this is our X-flare player, okay? So we're definitely beginning to get, when you start seeing new flares from, on the sun, it's not so much this region. It still is, but this region's disappearing. This is the new one to watch, okay? And if we have time, when I do the deep dive, we'll talk about what's on the far side. Okay, so that will be a bit more informal because I haven't set up a bunch of stuff on that. So there is our solar disk right now. And I'm about to switch to something else. Here we go. Okay, so now as I take a look at Enlil, this is a solar storm prediction that I do believe is not for this solar storm. I do believe it's for the one that we talked about that looks like it's still coming. I do believe that is what this prediction is for. I don't think it's a late prediction of the other one. So as we take a look at our solar storm prediction model, this is NOAA's version of the model. Top panel's density, bottom panel's velocity. You're looking down at the sun from the North Pole with Earth being off to the right. And as I start this thing up, hold on. Okay, there we go. You can see, you can see the solar storm coming out here. It looks like it's pretty much, it's a little bit to the west of Earth, but still reasonably close. As you can see the little poof right here. This is what I'm talking about with these stealthy solar storms. They look like they're really weak, okay? And so that's what you're getting is this tiny little poof of something that's going slightly north of Earth, not really, but, a little bit west, because you're looking down at the sun, or down on the ecliptic plane here, it's going off to the west, coming out. And also, if you look at the vertical cut from the North Pole of Earth is here, the South Pole of Earth is here. So this is a north-south cut. You can see it's going slightly north of Earth, but really not giving us much, right? Expected to be a peak for this structure, or at least a good impact around 11 UTC on the 3rd. I do believe this is the one is still coming. I don't think it's the one that's already hit. But as you can see, NOAA is not expecting much from this. But if you see that their forecasts are a bit enhanced, it's mainly because of this, and then also because of some fast solar wind that's going to be coming from those coronal holes that we were talking about. So you'll see that, and then possibly some polar effect from the polar coronal holes. But you can see some of the fast solar wind coming from an equatorial stream here. Okay, so get ready because we might have yet another storm coming. As far as this one's concerned, we're probably going to be dropping off in terms of intensity. This one is now beginning to die down. It was earlier in the storm. But for those of you, and pardon me if you hear a helicopter or something going by, for those of you who are out doing aurora hunting, there will, especially at high latitudes, there will still be a decent chase, maybe even at mid latitudes. So we are passing through the third quarter phase, and we're on our way to a new moon, with the new moon being on the 8th. Okay, so that kind of nice. You know, you've got a chance to get some decent aurora, even if the aurora is a little bit dim, because the moon is, you know, there's just not much left of it right now. So that's going to be a nice positive thing for you. Now, let's switch to our solar storm conditions and aurora possibilities over this coming week. At high latitudes, NOAA is expecting major storm conditions on the 3rd. You know, so for tomorrow, this is part of that second storm, or the third storm really is what it is. You'll see in my deep dive that this will be the third storm that should be arriving. So NOAA's expecting major storm conditions. In fact, you have about an 80% chance of is it 80 or 60? 80% chance of either a major storm, like staying up at a major storm, or even going into the severe level. Easily a G2, possibly more than that. We'll just have to see. It's really been tough to tell because you just don't know how strong these storms are. Their signatures on the disk and in coronagraphs are terrible. So you kind of just have to punt. And then I'm expecting minor storm conditions. I don't expect it. I expect it to calm down a little bit, but not quite as fast as they believe, because we're going to have that fast solar wind hitting us right around the 5th. We might be doing a little bit of a wind watch on the 4th. It all depends upon how that kind of unrolls. But expect a bit of some fast solar wind to come right around the 5th, and that could bump us back up and keep us at active conditions and keep that you know, the chances for aurora going. Now, on the 6th, we're probably going to be experiencing mostly just the fast wind. Things might be calming down a little bit. And then by the 7th, finally, we should be able to get a little bit of quiet, unless, of course, region 3663 starts becoming a solar storm producer, or if we get new regions that are rotating into Earth view to start firing big things. It's kind of hard to tell, but we have some big regions on the sun's far side that'll be with us in about a week. So don't expect things to stay calm for very long before things start building back up again. Okay, now if we switch to our mid-latitude solar storm conditions and aurora possibilities, again, minor storm conditions, in this case, at a G1 watch over the next day or so, about a 35% chance of a major storm. This is what NOAA is saying. And I've got us at active conditions for the 4th, expecting things to calm down a little bit. The wind watch isn't that strong for you know, the aurora possibilities at mid-latitudes, because I don't think the wind is going to be that fast. These coronal holes are reasonably small. And yes, it will continue into the 6th, but again, we're going to be calming down pretty quickly. So only about a 15% chance of minor storm conditions with that fast solar wind. And then finally down to unsettled and only about a 25% chance of active conditions starting around Tuesday. However, this is going to last for only about a week before, you know, I mean, through this week before things will pick up. I mean, I really expect within a few days after this, maybe by the end of next week, we will be back to possibly storming conditions, if not storming plus big solar flares. Now, as we switch to solar flare and the Dayside radio blackout outlook over the coming week, we are sitting at about 140 right now, I think about 142 today for solar flux levels, which means good radio propagation. Things are going to be dipping down a little bit over the next couple days because that region 3654 is moving to the sun's far side, but region 26, what is it, 2633? I forget now. I forget the number. The one that's beginning, the big flare player that's beginning to get big, that one that's rotating to center disk right now, that one may cause a bit of rise in the solar flux again if it continues to grow like it is. And plus, we do have some new regions that are going to be rotating from the sun's far side back in view. So that will likely boost that solar flux back up to 140, possibly higher by Tuesday or so of next week. NOAA is giving us about a 65% chance of an R1 to R2 level radio blackout over the next day or so, which you can see is kind of dying down to about 50%. That will stay. That's not going to go down any further unless some of the regions on the disk right now actually quiet down. We also have about a 15% chance of R3 level radio blackouts. Those are X-class flares But again, that's going to die down just a little bit. But again, we do have that new region that is an X-flare player. So expect radio blackouts to continue to stay with us. Sorry, I was hoping we were going to get a break from them, but nope, it doesn't look like it. And into next week too, we will likely continue to see more radio blackouts just simply because we have those bigger regions from the sun's far side that will be rotating back into view. Okay, oh good, whoops. And I hit the advance right when I didn't need to because I was already switching. Let's try that again. Okay, so looking at our radiation storm and polar aviation outlook over the coming week, everything is in the green right now when it comes to radiation storm levels. We're at the D1 normal range. That's at flight level 360 for you aviators, which is also the S0 quiet level for everyone else. We right now have about a 15% chance of a S1 to S2 level radiation storm, and that is because region 2654 is rotating to the sun's west limb, and we have all that cluster of regions in there. Anytime we have regions that are big flare players rotating to the west limb, that always makes that radiation storm risk rise. So we will be elevated for a couple days, and then we will begin to kind of calm down just a smidge. May not be calm for that long, again, because, you know, we're not getting rid of these big flare players anytime soon. So if you happen to be an aviator, definitely check those ICAO advisories reasonably often. If you're flight crew, everything is cool right now, but just stay on your toes and stay advised. Frequent flyers, same thing. Just make sure you check those advisories and consider any changes in your flight plans. So this is it for the BLUF. Hopefully I didn't stay on too long. I see I took a little bit of time. But for those of you who now are like ready to go to bed, you know, feel free to turn everything off and go to sleep. We don't have right now the G3 levels of that storm that we had earlier have been dying down. In fact, if really quickly, I will, just for those who might still be hanging on for a second before Betty bye, let me go to, whoops, oh hello, that works, doesn't it? Let me wake up the computer. Yes, I used two computers here to, oh, that wasn't what I wanted you to see. How about this? Or this will be better. Okay, so for those of you who don't like big plots, I will explain what you're looking at. If I can scoot it over and give myself some room. Oh, poop, I can't. Oh, well. Huh. Maybe a little. Scoot it over a tiny bit. No, it zooms in too much. So I want you to see the timeline. You can't see the time. You know, we need to make these plots more user-friendly, presentation-friendly. We don't have that. Okay, so what you're looking at here, this is why I wanted to show you this. What you're looking at here is, I'll keep it like that, the magnetic field, the solar wind, basically, all the solar wind parameters. And what you're seeing here over the past, this is just the past 3 days. So believe it or not, this right here, this period, and you can see it on Twitter. I posted this also on Twitter and also on my Patreon feed. This is Solar Storm 1. This is the first stealthy solar storm that hit us yesterday. The reason why I talk about the fact that this thing was kind of yawn-worthy was because when this thing hit, we had a little bit of southward directed field. That is the red going below this line here. So all this stuff that you see peeking, peekaboo beneath my hand, that's all southward field. But look, as soon as we got into the core of the solar storm, which is this structure right here, this field went whoop and flipped positive. So it went up, really high up. And so it's above this line, which means it's northward field, which means it turned into a bumper car because its magnetic field was aligned the same direction as Earth. And so it's like having two fridge magnets that are the same polarity. You push them together and they just repel. They just bump off each other. But when this field goes southward, so if that red line is down here, that means the magnetic field, one of the magnets is flipped. And so you know when fridge magnets go and click together, right, that makes their whole system one. They become one magnetic system, and they basically are able to pump all of this energy from this solar storm right into the Earth's magnetic system, and the Earth system goes like that. And you get Aurora, among other things. So you can see this thing was very, very northward, which was very, painful for Aurora photographers who thought that they might actually get a nice storm. This is why I wasn't super vocal about it on Twitter or anywhere else. It's because I knew it was coming, but it was, first it was a stealthy solar storm. We expected stealthy solar storms to be simple and ridiculous, and I didn't want to get everybody's hopes up. Then when the thing hit, it was like, wow, this is strong. Because this thing was like a 10 to almost 15 nanotesla magnetic field, and that's strong enough, especially when you're going almost 400 kilometers a second, which is kind of where we were. So I was like, oh, well, okay, it flipped northwards, so I guess I made the right decision. And then as soon as this thing began to calm down, we're thinking, okay, it's over. We were looking at other stealthy signatures, myself and other forecasters, because I chat with them, some of the NASA and the NOAA forecasters and the 557th. We're all kind of chatting behind the scenes about some of the structures we've seen and how messy they are and how much of a headache this is. And then bam, we get hit by this. And look, oh look, you've got that line I was talking about and the peekaboo stuff you see beneath my hand. There's a lot more of it, you notice? And so not only did we get hit by a stronger solar storm, this right here, but it's all southward field, right? And southward field here again. And now a little bit of southward field, but this part isn't gonna. So this is what caused the G3. Okay, we got hit and this was kind of like a G2, and then it went north and we thought, okay, well, it's just gonna do exactly what this structure did. That's what I figured. And then it went south again. I was like, whoa, wait a minute, something else is going on. And then we got to G3 levels very, very quickly. So for a while I was thinking, ooh, this thing might last, through the entire evening, but obviously it hasn't. I don't think that we were like directly in line with this structure. I think it was to some degree. Let me look at the other component. I don't know, maybe this thing was just really distorted. It could be that it was just extremely distorted because this, I mean, you saw the coronagraph looked horrible, right? All this junk in the middle of it. So this is what we're dealing with right now. As you can see, it's calmed down quite a bit. I think it's going to continue to calm down. The interesting thing, though, is that the solar wind speed is picking up, and there's a reason why that's becoming interesting. Okay, we're up at over now almost 500 kilometers a second if Discover is to be trusted. And why I find that interesting is because the faster that yes, it can be trusted because ACE is also at 500 kilometers a second. So we've gotten up to 500 kilometers a second, which is reasonably fast. And the reason why I find that interesting is because if I were to look at this data, I guess I'll just make it big. This is EPAM data. I know, once again, time series, very boring. But what we're looking at is these particles rising, the flux is rising. And why that's important is that this often tells you if there's another structure, a steepening to a shock or a shock wave coming at you. And granted, some of this stuff, it's kind of hard to tell. This was beginning to die down. This is basically where the second solar storm, it kind of hit in here. And so it looked like it was going to peak and then begin to die down. You can see some of the particles began to tilt downward, right? The slope started going down. So it's not clear yet whether or not there's something still coming. But what got me curious was that as I was watching this unfold, the lower energy stuff, that's what this stuff is, that's the one that's continuing to peak. It's continuing to climb a little bit. Now I see a little bit of curve off right here. Don't know yet. We have to just kind of let the data trickle in. But if this thing continues to rise as we get closer to whatever else is coming, if there's a shock or a steepening wave or something like that that's coming toward us, these particle populations, these higher energies, will also begin to rise again. But they don't typically rise until you're really close to the structure. This one will rise sooner. So we're keeping an eye on it. Now, could this simply be some fast solar wind, shock from faster solar wind? Yeah, possibly. But it also may be that other stealthy solar storm that we talked about that I showed you, during the BLUF, where NOAA had done the model with that very weak solar storm. Yeah, well, NOAA had done a model of the weak solar storm, and we had all thought things were going to be weak, but the last two solar storms have been magnetically strong. So that's the problem with these stealthy solar storms, is that they can oftentimes be magnetically strong, and they then cause a big impact. And we get caught saying, oh, this isn't a big deal, when in actuality it is. So this is the problem that we have with big solar storms. As you can see, here is the HP30 index. This storm at times was getting us above, above the level of a G2, upwards, almost upwards. Well, at one point, I think the real-time data, when I saw this earlier, this thing actually had gone a lot higher, or in G3, a little higher than a G3. So yeah, because what KP5 is G1, KP6 is G2, KP7 is G3, so we're a little bit higher than a G3. And that, you know, twice. So this was an impactful storm, even if it didn't last all that long, because it could have. So stealthy solar storms are going to continue to be an issue for us over the course of, I don't know how long. But in the deep dive, I'll stop here and answer some questions for you guys, and then we'll jump into the deep dive, and I'll show you some of the techniques that I've used to uncover some of the details of these stealthy solar storms, and what are telling me that, you know, even when I see these little weak storms, possibly I need to actually forecast them and let people know when they're going to come, even if it means that you guys are, you know, bored, because there'll be a lot more false positives. That's the problem. And I don't like a lot of false positives. So anyway, let me know what you thought of this. If you have questions, what can I what can I say? Okay. Let's see. Does the weakening Earth's magnetic field play a part in this? Not really, to be totally honest. It's really not playing a role in this at all. I always tease because there are so many. If you go back to the 1950s, we had so many more storms that were so much more intense than this. I mean, people see oh my goodness, are we having an M6.6 class flare right now? Guys, do I need to, let's take a look at the solar flare data. Oh, beautiful. Oh, look, and it's from our friend. You can see right here, look. See that? That's our region. That's our 3633. Well, I forget the name of it. 3663. What the heck is the name of that region? I'll look it up in a sec. But yeah, take a look, guys. Let's do 6-hour data. So there we go. So we have an M6 point. Where are you? Oh, an X. I'm sorry. Why did this say? I missed the X. Oh, X 1.4. Thank you, Mark. X 1.4. So just as I'm talking about having this big region, you know, taking over, I think it just did. This region just took over. We just had an X 1.4 flare while we were doing this thing. Let's take a look since we're here. Why don't we take a look to see whether or not there was any coronal mass ejection, meaning solar storm launched? I bet not, but we shall see. Okay, help. Come on, Suvi. So this is, for those who care, this is the 191 angstroms, or 193 angstroms. So 193 or 195, I forget. Yeah, there was a CME. There was a coronal mass ejection being launched. Okay. This one looks like it might be going north of us. I am shocked, to be honest, that this was an X14. Wow, it looks so tiny. You can definitely see a bit of a blast wave. Can you see that blast wave going off? You'll see something propagate across. But if you notice, most of the blast wave looks like it's going this way, and it looks pretty well contained in this region. It didn't even dislodge this filament below it. That's why I'm shocked that that's an X. Gosh, it sure doesn't look like an X-class flare. Let's see. No, and that one happened before, so it's not like several. I'm standing out of the way, making sure that there weren't several flares. Whoops, can I get? I don't want that stupid little, here, zoom out. Where's the, never mind. I was trying to get the time for you, but trying to get the time for you is kind of silly. And now I've got this stupid click to exit full screen again. One more time. Let's try that one more time. See if I can get... No, see, I can't get this stupid thing to... There, maybe I can keep it there. Keep it away from me. Okay. So, what I am studying right now in real time is around this disk, looking for anything it might have shaken loose. All I see that's shaking loose is the upper tier here. I slide this down. Yeah, I see stuff blasting off this way. So I would not be surprised in coronagraphs if we end up getting something more this way. I don't think this is going to be... if there's any part of this that could bother Earth, it will be a glancing blow. Plus, here's the other problem. We've got coronal holes here. So what happens is that fast solar wind kind of makes a wall. So if something's launched above it, oftentimes it gets deflected away from the fast solar wind. So this could be, if it's going to do anything at Earth, it might be a glancing blow. Let me take a look and see if we've got anything from, I seriously doubt we have anything from coronagraphs yet. And I'm sorry I didn't get to anybody's questions yet. My apologies, but you know. Do we have any chronograph data yet? I don't even want to go to stereo. So there's another CME. Whoops, I'm standing in the way. My apologies. Nothing. Not yet. What is the latest time we have? 2300. And this happened, let's go back. Oh yeah, no, we've got some time to wait because this just happened now at a few, you know. It's, the peak of this was what? 225-ish, 220-ish on today, on the 3rd. And look how tiny, look how tiny. So this is what I'm talking about. Very impulsive flares. Impulsive flares don't typically light off and launch big solar storms. Look how, just like tiny little needles, right? These ones are the ones, these are called gradual flares. See how wide they are? Look how wide they are. These are the ones that typically launch solar storms. Even something like this will launch a solar storm. But these tiny little needles, not so much. So that's why I said, there probably wasn't much there. So we'll see what goes on. But what's driving me crazy is that because we're getting so many of these things that are rearranging local field configurations, but not blowing off large portions of the sun, you know, the sun's overlying field, these stealth CMEs are just lighting off like crazy. I actually missed the time when we had more gradual flares where you'd have big coronal mass ejections like launching, these big solar storms launch off the sun, and it would just evacuate a huge swath of the overlying field of the sun. And so we wouldn't have these stealth CMEs because they'd get swept up with everything else. All these stealth CMEs that are just thinking of launching, they'd go bye-bye with the bigger eruption. And so, you know, you'd never see so many stealth CMEs. But right now we're seeing a lot of them, and it's really frustrating. So much so that I'm actually back in contact and chatting with some of my old ISSI team members because they're just aggravating. This is such a thorn in the side of space weather forecasters because we just don't have the tools to deal with this, not at least in operations. In academia, sure, but not in operations. Okay, sorry about all that, but you know, hey, we just had a big flare. You have to expect I'm going to get excited. This is the first time that I've seen an X 1.4 happen on a live stream. Cool, love your excitement when you noticed it. I know I'm like a kid in a candy store. I'm like, oh, cool. You know, you get to see how the magic works, and I don't know. Depending upon what people want, I will show you some of the other tools I use to analyze this, which I would end up doing after the stream anyway. So it's kind of the end. So is this the end then? The end of what? The end of the world? No. The end of my live stream? No, because I'm going to go into the deep dive here. I just wanted to make sure that I answer some questions prior to that. Are those shock waves? You mean on the sun? Yes, those are shock waves. Those are those blast waves that you see? Yes, those are definitely shock waves. Well, also called Morton waves, EIT waves. There's all sorts of names for them. And they represent a lot of different processes that are going on in the sun and a lot of particle acceleration. Really neat too, because really cool eye candy, because if you look at the sun and the right wavelength, you can see like the magnetic loops because they're populated with all this plasma. And so they're lit up kind of like neon signs, and you'll watch them just go like this, kind of like reeds bending in the wind when this blast wave goes by. It's really cool. Okay. You came in just right at the right time. Oh, Robert, that's cool. I'm glad you're here. From the Philippines, that's awesome. Thanks a lot. You're very welcome. Thank you. This is Degla Moore. That's so cool. Degela Moore? I can't. Your name went by too fast. I probably should put the chat back up. Here, let me put the chat back up so you can see yourselves. Okay, Cool. All right, and Jerry, you said, oh yeah, Jerry, you're answering questions. Thank you. Yes, the sun from the Earth's perspective rotates in about 27 days. So it actually rotates in about 24 days. That's an average rotation because the equator rotates faster than the poles do. It's what we call a differential rotator. And that is very critical clue, or actually a critical part of how the solar dynamo, the magnetic dynamo works on the sun, is the fact that this thing is not rotating rigidly as if it were a single piece of rock, because it isn't. It's a big ball of magnetized plasma gas that's charged. So it's really cool. Okay, let's see. The sun makes up its own rules. There's no doubt, I tell you, and it's tough getting its mysteries unraveled. Awesome and helpful ham radio operators in this community. Yes, absolutely. The ham radio operators in this community are incredibly savvy, and they know their space weather. And they help me behind the scenes as well as, now in front of the camera. They help me immensely. That's why I had to become a card-carrying member of that community, because they're just wonderful people. So if you ever want to become an amateur radio operator, you will enter into a family that is they're just amazing. There's nothing like those people. The Aurora community is amazing too, and they're in a different way, but they're also wonderful. I want to get the two communities closer together, actually. Okay, any other questions that are regarding the forecast? Last time I will ask, how can my local ham radio group invite the doc for a presentation to our group? This is Robert Christian. Robert, are you a member of my Patreon community? If you are, then you and I can chat much more readily, and I make special space for my Patreon community. And sadly, there is a long list of people that want me to talk, and I just can't. I've spread myself so thin. So keep coming at me, and I eventually, will eventually get you set up one way or another. But yes, there are quite a few radio clubs that want me to talk with them, and I will. It's just a matter of needing to clone myself to make it happen. So don't give up on me, Robert. We'll connect somehow, okay? And it's a lot easier if you're on Patreon. Again, you don't have to subscribe or anything. You guys can just follow me on Patreon. You don't obviously get access to certain things, but you can actually see what's going on, and you can contact me that way. So that's a lot easier. Is this X Earth directed? No, I don't think so. I'll look at it more deeply when I go into a deep dive if you guys want me to. But it's a flare it's not the same thing as a solar storm. So an X flare is not the solar storm that's launched. Solar storms and solar flares are completely different phenomena. They oftentimes happen together, but they don't always have to. So what you're asking about is a solar storm that actually, there was a very small one, potentially small one being launched, and it looks like it's going mainly north of us. But I have to do a bit more analysis, and we have to wait for coronagraph images to know for sure. But I'm not impressed by this X 1.4 flare. There was not much of a storm that was launched at all. I see much better for big solar flares like that. Okay, let's see. Tama, the 13 states have QSO parties this Saturday. We need a quiet sun. Ain't gonna happen, Jerry. Sorry about that. Phil Lewis says, roughly how long will it take to feel any of the effects here? Effects of this radio burst right now. Actually, I don't know if there is a huge radio burst, but if I go to the DRAP model, you will see. Now, this is not data, but it's pretty dang representative of what people see and feel, at least qualitatively. So I'm sorry I've got all the comments back up, but you'll see if I move and fast forward to here, 5.3. So this is right now. See if I can scoot it over. I can't scoot it over. You'll see this thing get big real. There it is. That is the X3 flare. The X1 flare. If I pop back here, I'll pause it so you can see the areas affected. Okay, obviously it's the Dayside, right? So right now, North America, even Europe, we're all in the night side, so you're not going to see it. If you can't see the sun, you can't hear it scream, and that's really what a solar flare is. It's the sun screaming. So only the Dayside gets affected. So Philippines, Donegal Amor, you're dealing with an X 1.4 right now. Sorry about that, but things will calm down within the next hour. So if you're anywhere in Australia, if you're in the Asian Pacific, you're going to be dealing with it. New Zealand, Tasmania, yes, yes, yes. China, Japan, anywhere in this, Indonesia, you're going to be dealing with it. So even parts of India, I mean, even if you get into here, you're going to be dealing with it a little bit. And sometimes these regions are some of the worst hit. So just be aware that, if you're having issues, if you're an amateur radio operator, you're dealing with, you're dealing with HF or even VHF comms right now, things could be a bit dicey for you. If you're an aviator, if you're at high latitudes during these events, that could be a real problem, especially in the northern tier right now because it's the northern summer. The sun is basically on your horizon all the time. So that makes it very difficult for you because the sun is always in your line of sight. Whether you're staring at the sun or the sun is behind you and it's, lighting you up, it's always still in that same line of sight. So that makes solar flares for people up in this region very, very tough if you're an aviator. So that's why I say look at those ICAO advisories. You're going to need them, or at least some advisory that lets you know that you're having these big R3 level radio blackouts. Okay, hopefully that answered that question. Do you have the magnetosphere monitor with the GOES X-ray satellites? The magnetospheric monitor? Oh, do you mean you want me to look at the GOES data and the magnetometer? Sure. Here's the magnetometer on the GOES data. This is the past day. This is the G3 storm that hit us. Let me get this crap out of the way. There you go. There's the G3 that hit us. Not a big deal. Lots of substorms. A lot of ugly little bumps here. But this is this Earth's magnetic field reconfiguring. So lots of substorms today. So let's see. On the night side of the planet. Yeah, that's the solar storm that's causing any energy on the night side. Right now you're seeing a lot of stuff. This is at noon, this is midnight. But the Earth's magnetic field, the way it happens, the way a geomagnetic storm occurs, most of the energy is in the night side. And then you slingshot this Earth's magnetotail, it kind of reconfigures magnetically and then is like a slingshot that slingshots the particles from the tail into the north and into the south to create aurora. You can, if you want to learn more about that, you can look at my YouTube courses, the M series for the magnetosphere, and you'll learn all about the chicken dance and the slingshot and really how the Earth's magnetic field deals with storms like these. So just joined. What did I miss? You missed the BLUF. I'm doing a Q&A now right prior to a deep dive. Are they reversing the strength of the current solar are they revising the strength of the current solar maximum? Yeah, it's always under revision. I think some of the algorithms that are being utilized now are literally every single time they get new data, they're revising their model fit and how they're, what the strength of the solar maximum will be. Is it going to be as strong as solar cycle 23? It doesn't look like it at this point. Do I think it's going to continue to get stronger than it is right now? Yeah, I do think the far side, the declining part of the solar maximum, because we're going to have likely going to have two peaks, just like we did last cycle. I think the second peak is going to be larger than the first. And so I think the declining phase, or the declining part of the solar maximum, is going to be stronger than the ascending phase. There's lots of papers and still not a lot of studies, but there are some studies that indicate that odd cycles have that interesting phenomena where they're stronger on the second half of the cycle, whereas even number cycles are stronger on the ascending phase of the cycle. Likely has something to do with how we couple to the galactic cosmic or intergalactic field, but that's speculation on my part. But it's something that has to do with the Hale cycle, which is a 22-year cycle. So that tells me that, well, you got to take a look at what the magnetic connectivity is to other systems, the systems beyond you. So hopefully that helps answer that question. I know it probably asks more questions than it answers, but at least it's something. Okay, could the recent activity be an indicator of the cycle maximum? Yes. Remember, solar maximum is not just a point, it's also a phase. Okay, so you can say, where's the peak in solar maximum activity? That could be a considered solar maximum, but then you also have a phase of solar maximum, especially when the two hemispheres, the northern hemisphere and the southern hemisphere, are asymmetric in their activity, which is what's happening right now. We have asymmetry in the hemispheres, so one hemisphere reaches solar maximum before the other one does. And so your solar maximum's kind of smeared out. That's why we have a lower activity overall, is because the two hemispheres aren't in concert. They're not overlapping each other. They're kind of side by side. So one reaches maximum and then the other reaches maximum. And that gives us the two peaks. So hopefully that helps. First time viewer, new ham. Oh, congratulations, David. I'm glad to meet a new ham, a new amateur radio operator. My knowledge on solar storms just quadrupled at least. Oh, that's great. I'm so pleased. Keep watching. Things will get even better, because this is more of a complicated briefing. So most of them are a bit easier than this one. This one is tough. Okay. All right. Let's see. Yeah. Thank you, Linda, for saying that. Welcome, David. Dr. Scove is great. The sunscreen. You go. Steffi B laughs at that. That's funny. What does dealing with it mean? How did I say dealing with it? In what context did I? Because I say that's a phrase I use quite a bit. So I mean, forecasters are dealing with it, or Earth is dealing with it. Usually it means it in the casual, frame that I'm saying it. So that was pretty funny that you if you want me to be more specific, let me know. Okay, can a solar flare affect barometric pressure? Oh boy, that's a loaded question, and that's my honest insight is yes, it likely can, but the main question is it measurable? Okay, because solar flares affect lots of things. They obviously affect charge layers. They affect ionospheric. As a matter of fact, ionospheric densities. We were just talking about. Do I even have that up? Maybe I do. Oop, hang on. Yeah. I hope. I was just talking with Andy Smith about this. Oh, come on. Are you not? Well, that's interesting. Oh, there it is. Okay. So here is an example from Andy Smith, who is looking at Doppler shifting of a signal, a 20 megahertz signal, during one of the solar flares. This was I forget which flare this was. This was the big M9 the other day. And so what you end up seeing is this signal is being changed basically by density changes in the ionosphere. And this signal going whoop like this is an indication that the upper ionospheric layer was pushed down, was actually like moving to a lower altitude. And when you have quick movements like that, so this is what Doppler shift does when it shifts up. That's what's happening. Don't ask me to explain the details at the moment, because it's a bit advanced, and it's beside the point. But why I'm invoking this and using this is because it's telling you that literally an ionospheric layer, a charged layer, is moving much, very rapidly down, and that is definitely going to affect temperature. It's going to affect convection. It may even affect the density and pressure, as we see. And so that layer, in this case, it's probably the F layer, but this happens, guaranteed this has to happen with E layers as well, and the D layer, because this is actually where a lot of the charged layers, get ion, or a lot of the layers get ionized. And so, so this might even be the D and E layer regions. And those are coupled really closely with the neutral layers. And that's where all the pressure is, right? That's where all the neutral atmosphere is, where you get all the density and pressure. I mean, that's the mass of our atmosphere is down in those lower layers. So if you're seeing this type of movement simply because solar flare is causing all this ionization in these ionospheric layers, and you're seeing movement of these layers moving down into the neutral atmosphere region, or getting closer to it, simply by watching a signal go Doppler, with a Doppler shift that goes up, then you know that it's going to be perturbing those neutral layers. And we know already that the neutral layers do perturb the ionosphere. We see it all the time in our ionosons and everything else. Spread F is a good example. Plasma bubbles. There's all sorts of examples as to how that happens. So yes, I do think it happens both ways. The trick is accurately measuring it. Okay, that's the problem. And so we need a lot more scientists in the loop who are willing to merge the two fields, basically, you know, the ionospheric physics that deals with particles, very vacuous particles in very highly charged and highly magnetized environments, you know, that they're paying attention to these environments. And then those downstairs in the neutral atmosphere who are looking at neutral particles that are highly dense, right? They're dense and they're hot and they're all, you know, they're collisional, and yet they don't care about electric and magnetic fields. So it's basically what I call the billiard ball regime. So think of pool balls smashing into each other. That's the neutral atmosphere, and there's lots of them. And then in the ionospheric regime, that's more like the spiderweb regime, where you have particles that may be too far apart to really collide easily, but they're attached to each other via like a spiderweb, a magnetic field spiderweb, magnetic field and electric field spiderweb. And so you shake this particle over here, and this particle will move because the web that's connecting both of them is moving. Okay. And if you shake that web, then all the particles pay attention to it. Down here, you shake the web, the particles don't care because they're all neutral. Okay. So it's two different regimes, but they couple. There's an interface between the two. We need more scientists that are willing to cross that interface. And we just don't have a lot of them yet, but we're trying to get there. That's part of some of the training I do at Millersville. Okay, hopefully that answers that. I know that's a long-winded question or a long-winded answer, but we are seeing, why are we seeing more aurora in southern states with weaker geomagnetic storms? Because we have cameras. First of all, we have cameras that are unbelievably sensitive. These cameras pick up air glow. They're so good. They pick up air glow. We're having problems now judging, is this aurora or is this air glow? Who knew with a cell phone camera that you could pick up air glow, let alone aurora? So our night skies are getting a lot more colorful just because of the cameras, the sensitivity of the cameras we use. That's number one. Number two, everybody has one of these, right? I mean, it's not, you don't have to beat around the bushes to find someone who's willing to step outside and take a picture of the sky at night, right? And number three, these things are also good at getting news really, really fast. Whereas decades ago, not only did we not have sensitive cameras like this, but it wasn't easy to go out and set up. You had to be basically an astrophotographer to know what you're doing. And you didn't have social media to say, hey, look at the sky now. Most of the time it was, look at the sky, 3 hours ago or yesterday. And so by the time people looked up, it was gone. Okay, these are the things that I'm talking about. So everybody thinks it's the weakening geomagnetic field, and it's not. We haven't even had a G5-level solar storm for more than 20 years. If you go back to the 1950s, we had G5-level solar storms 3 times a month during solar maximum. And we didn't even have a single geomagnetic storm at the G5 level for the entire solar cycle 24. Okay, it's not our field. Our field is fine. And I get upset because I'm tired of this. People, you know, if anything, the power grid companies are very happy that our geomagnetic field is dipping, and they call it an excursion. It may not even be flipping. We don't know this yet because there are so many historical examples of when the field did exactly this and then it recovered. So we can't even say with any fidelity whatsoever that the geomagnetic field is indeed flipping. And it isn't even the whole field. It's only the dipole component. That's just one of a whole series of components. So if the dipole field flips, then we have the quadrupole field to protect us. And people have already done studies to show that we are not in danger of having our atmosphere stripped off or anything else if we have a quadrupole field instead of a dipole field for a while. The sun does this every 11 years. In fact, the sun that you see right now is a multipolar sun. It is dominated by a quadrupole component. Okay? So if I go back and look right at the sun right now, it's just fine. And there is no dipole field component in this sun right now. Okay? The dipole field component has disappeared right now. This is why the sun looks a mess, but it's still fine. The quadrupole field component is obviously still up and working because we are getting solar storms, right? The Earth does it too. It's just not quite this messy. What's going to be a mess is our near-Earth space, because we're used to radiation belts. We're used to having a very ordered set of particle regimes in the Earth's magnetic system. And when we go to a multipolar Earth, that is going to be mind-blowing, trying to understand what the space environment is going to be. That's going to be a bigger deal than even us being down on the ground. Now, is it going to affect aviation? Yes. Is it going to affect particle precipitation? Yes. Those are things I'm concerned about. I am not concerned about power grids. I am not concerned about solar storms. I'm really not. And people who push this stuff are just trying to get your heart pumping, because they're not looking at it the way they should be looking at it. Power companies actually appreciate having a weaker geomagnetic field, because that means the currents that are induced into the ground, that get induced into the power lines, then are also weaker. Okay? When you have weaker GICs, that's what they're called, geomagnetically induced currents. When you have weaker GICs, the power grids don't get affected as much. It makes it easier to block those currents and preventing them from getting into the lines, which is what they're trying to do right now. So it's actually a positive thing if our field dips a little in strength. Okay? So don't believe the hype on YouTube. They're just riling you up because it's clickbait. It's just, they're not grasping the physics and the impacts of the physics. They're just running with an idea that is not based in reality. Okay, anyway, enough of that. Red auroras in Arizona in 2023 is indicative of this. How many missed forecast has NOAA had this year where they were saying we're going to have a G1 and it goes to G3? You want to look at a G3 like this? Oh, I should take the, let's see if I can move this. How can I move this? You mean a G3 like this that lasts 6 hours? This is not a big deal. We have, even the one that happened prior to this that had a G3, it was only 1 bar. It was 3 hours. And it was more from an impact that was just an impact from the solar storm hitting Earth. And then the whole thing went northward, or the whole thing kind of fizzled out. It was just the impact that way. The one big G3 that we had, as a matter of fact, that thing ended up being a bumper car. So, you know, during solar maximum, these types of storms are common. And you know, I think there's a lot more people pushing this whole geomagnetic field flipping craziness now, because I'm getting a lot more comments on it now than I've ever gotten. Let me show you. Now, many of you probably do not know that what you are looking at, and I'm going to turn the chat off for a second, off of the main screen, so you can see. Getting more than you bargained for this evening. This is called a Bartel's musical diagram. This is KP. Okay, this is a wonderful way to look at KP. Probably have never seen anything like this before, unless you've taken my Millersville classes. Okay, here are big storms. You can see them because they're dark. Am I going to go through the scale? No, you can go through the scale yourself, because that's not the point of this. The point is to say, when you look at a Bartel's musical diagram, you can see very quickly where big storms are. Okay, there's a big storm, there's a big storm, there's a big storm. Now, it is organized in such a way that you can actually see the entire year very easily. So if I go, if I go to, let me do, there we go. What was a good year? 2011? Oh, I want the whole year. Here we go. Oh, don't do that. Just let me see the picture. Okay. So I'll stand on this side. Okay, so here we are. This is the entire year of 2020, or of 2011. Okay, if you recall, 2011 was one of the biggest years of solar storms in solar cycle 24. Okay, so we're at solar maximum, right? And I'll even show you 2012 and 2013 and 2014, just so you can feel the love, okay? This is an entire year of KP data, meaning solar storms, right? Can you see the big storms? Just look for the black. Okay, 1, 2, 3, 4. Okay, when they go all the way up to the top, that's a G5. Okay, what I see here is a G, possibly a G2, G2, G2. Maybe this is probably a G3 for just a moment. This is another G3 for just a moment, and that's it. You can count them on one hand. Got it? And they may go up to G2, maybe a G3. That was 2011. Let's look at 2012, if I can find it. (2012), okay? Once again, maybe there's a G2, maybe a G3, G2, G3, G2, G3, there's a G2 or G, probably G3, G2 or G3, G2 or G3, there's a maybe a G4, right? Then these tiny little, that's it, the entire year. Again, how many, maybe for big ones like G3 and above, again, you can count them on one hand, okay? That was for the entire year of 2012. (2013), I can do this all day. Worse. Remember I said the ascending phase of last solar cycle was better than the declining phase? Right. Okay, we had one, maybe a G4, lasted for what, 3 hours? That's 1 bar. The rest of them, G2, G3, maybe, for a short-lived time. 2013, 2014. Laughable. 2014 was one of the years of solar max. We had 2 solar maximum years, 2014 and 2015. There's a G2, there's a G2 or G3, barely, right? The rest of the year, nothing. If you don't believe me, you guys can go look at this, okay? This is KP for the entire year of 2014, okay? It starts halfway because if you look at the calendar, you look at these days, it says 1 through 27. Those aren't days of the calendar year. These are days of solar rotation. These are what we call Carrington rotations, so that you can look down each Carrington rotation and see exactly the stuff that was going on exactly when the sun rotated back to where it was 27 days prior. So if there happen to be coronal holes or something, you will see them in successive lines because the storms will keep coming every single line, okay? They're set up in a particular way to read them in a particular way. But they're very good at getting you to see what is happening on the sun and how, and doing solar climatology, which is really what KP was made for to begin with. It was never even made to do space weather. It was made for climatology. 2015, hey, finally we get some storms. Goodness, thank you. Finally something, okay? We got a little bit here, right? We got a G2, G3, G3, G3. Yeah, it looks like it. G2 probably, G4 here. There's probably the big one, but it only lasted for, you can tell it's a bumper car because it hit hard and then died down and then something else. Maybe the same storm, maybe a new storm. There's a more solid G3. Maybe G4, okay? We got a few, finally, 2015, okay? If I were to go to 2016, it'd be more boring, 2017 really boring, because now we're beginning to really go down the descending phase of the solar cycle. Did you see any G5s? No. Now, what was solar maximum solar cycle 19? (1953)? Maybe not 1953, maybe before that. Again, so this is definitely when our geomagnetic field was strong, okay? Do you see anything that looks out of family? Okay. Let me go back to 50. Let's go down now because I may be at the declining phase. I forget exactly when it was. Might have been 1950. I can't remember. Oh yeah, this is looking more active. How about this, guys? So obviously not 53. Maybe 52, 51, maybe 50. I'll go back and keep looking. Can you imagine storming for 2 weeks straight at a G4 level? Oh, look, here's a G5. Here's a G4. Here's a G4. Okay. Does it look a little bit darker? A few darker spots? Do you think our Earth has been through more than this? This is harder storming than we've seen at all. And this is just 1 year. You could probably take the entire solar maximum for 2013, 14, 15 and stack them together, and you may not get as much black on the screen as you have with just this 1 year. This is what I'm talking about when people talk about kill shots with what we've seen this recently, and I just roll my eyes. You guys are being fed a bunch of bunk. You don't know what storming is. Look at this. This is 51. Did I do 52? Yeah, I did 52. CG5? CG5? Just a Carrington rotation later. 2 G5s in less than 30 days. Or about 30 days apart. Storming at the G4 level or G2 level or higher consistently for a week. Have you ever seen anything like this in your lifetime? Likely not. Our Earth can handle so much more. Do you see this? Here's 1950. Again, G3, G2, G3, G3, G4, G5, G5. Do you get me? 2 G5s just in this year. 2 G5s in the year after. This is what our Earth is used to. This is what our Earth deals with. So we've had lots of stronger storms. It's much more what the sun sends at us than whether our Earth's magnetic field is weakening. The kinds of storms we see today are a joke. This is why space weather forecasters who've been in this field for more than 10 minutes recognize that there's a lot more to how much complacency there is than just a weakening geomagnetic field. Okay? Our sun changes dramatically on timescales that are longer than the careers of space weather forecasters. The people who are alive dealing with the radio bursts, this is just solar storms. If I were to show you the radio burst data, your eyes would just go blurry. We had radio bursts that were insane, okay, compared to what we deal with today. And I'm far more concerned about those because of our GPS-reliant world than I am, honestly, about geomagnetic storms and getting possible Aurora and having power grid companies have to deal with mitigating procedures that they already do. You know, those guys actually are the most on it of everything. But the aviation industry, the emerging drone industry, our ubiquitous use of GPS and GNSS, we are not ready for a sun like this. Okay? Those are the things that keep me up at night, not Earth's excursion in its magnetic field. For those who want to go and learn more about Bartel's music diagrams, GFZ Potsdam is such a fantastic place. Okay? They have records upon records upon records. Magnetic indices that go back clear back to the 1800s. It's fantastic. Okay. And I cannot say enough of wonderful things about these guys. I use their site all the time and their data products all the time. They're wonderful people. Okay. You should be president. No, I'll get off my soapbox now. I just want to kind of inject a little sanity, into this. Just want to inject the sanity because We have too many people running amok on YouTube, scaring the bejesus out of people for no good reason. People who weren't even alive and have never studied the 1950s. Not like forecasters have. Okay. Hopefully that helps people understand, right? And helps people realize that, no, we're not on the precipice of a disaster that's going to kick us back into the dark ages. And it's you know, I feel like I'm a broken record much of the time because I'm only one person, and I can't seem to combat all the noise that comes from so many different directions, because there are so many YouTubers that keep saying the same stuff over and over again. And you're if any of those YouTubers are listening, please just rein it in a little, you know, because you're scaring people. You're scaring people, and it's not, it's just bad juju. You're scaring people, and there's no need for it. There's just no need for it. Okay. Let me check on Patreon to see if people have asked me any questions. And if you guys want me to, I will talk about a deep dive here. Let's see, guys. Has anyone asked me questions? Not there. Good, okay. So hopefully that helps answer some of the questions you guys have. And if you want, I will. Your baby, Miss Marcian, was born in the 1950s. Yeah, that's the problem that we have. Scaring people is the purpose. I know, EE. It's just awful. It just makes my heart ache when I see what. To me, it's just predatory. You know, life is scary enough. We don't need that stuff. The 1990s was a big solar storm time. Yeah. Our cycle, we were still in the grand solar maximum. Obviously, cycle 19 was the biggest, but then we still had several cycles as we went through it. And cycle 22, the 1990s, in fact, that was the last really big cycle. And then when we went into the 2000s, that's when everybody started noticing a strange change. And I was a grad student in the early 2000s. And so I came into space weather studying the older cycles, right? The cycles of the 60s, 70s, and 80s typically. And then when everything started changing in the cycle that I was in, I was noticing changes. And then as I was getting to graduate and start, you know, working as a you know, doing research as a not really a postdoc, because I never really did a postdoc, but I was doing research once I got out of grad school. And I was noticing the solar storms they didn't look right. They looked weak and ratty and really kind of chewed up, and they were what we call high beta structures, and they just weren't these pretty magnetic clouds that I had cut my teeth on as a grad student. So I started really kind of going back and looking and realizing that, wow, the sun really can be incredibly variable, and how lucky I was to work and do my research during a time when it was easy to define when a big solar storm started and stopped. As a matter of fact, I didn't even have to look at the magnetic field. I could simply look at the plasma data and look at the temperature, because the solar storms back then, they were very cold. They were cold and not dense at all. And so you could just look at the plasma and see when the storm turned on and when it's turned off. It was amazing. And you go back up and you look at the magnetic field and you go, yep, exactly. They were very easy to identify. You go into cycle 23, into the 2000s, things got really ugly. And you couldn't see anything anymore. It was really, you could kind of tell that they weren't pretty, and it was just a mess. And they've gotten better, but only since basically the end of cycle 24 did I start seeing some of the prettier structures return. So I know we are definitely, and in solar cycle 25, we've seen quite pretty magnetic clouds. They're not quite cold yet, so they're still kind of hot, and they're still a little bit on the ratty side. But we're seeing a lot more of the structures that I grew up with. So that's how I know the sun is kind of returning to its old days. And so as we see bigger storms come, well, our sun's magnetic field is stronger, so it's sending out stronger solar storms. And everybody goes, oh, it's the Earth's magnetic field collapsing. It's like, no, you don't understand. Our sun used to be really, our sun used to be George Foreman, right? Now it's like this wimpy, 15-year-old trying to, box around. It doesn't have the same impact. But as it begins to return to its heyday, its Muhammad Ali days, right? It's becoming the boxer it once was. And so everybody's freaking out that change is all due to Earth, and this much of it is due to Earth. It's due far more to our ability to watch Aurora, our ability to capture Aurora, and be alerted and capture it with these incredibly intense cameras, sensitive cameras, and then of course just the sun sending bigger storms our way now, bigger ones than we've ever seen. Okay, I'm learning what fear porn points is. I'm gullible. Well, the thing is, you're not gullible. That's just it. When it comes to space, and I've said this so many times, when it comes to space, everything it's a potential to learn, right? This is why space is so cool, and why space is so unknowable and so awe-inspiring, is that we know so little about it, that anytime there's a show on that talks about space, or a documentary or anything, people they twist their head around and they go, ooh, I might learn something, because we just don't have enough information about space, and we're always trying to fill that void. And it's always so fascinating, especially for us space nerds anyway. And so when someone comes on and they act like they know and they're an authority on it, you're going to think, because you don't have any other litmus test to know whether they really have done all of the research they need to do or not, because they will have some knowledge. And so you're going to want to suck that up. You're going to want to become more informed. And that's really what it comes down to. It's not so much about being gullible. You're not listening to a snake oil salesman, but you want to become more informed about space. And so you go to the people who, act like they're authorities. And sometimes those authorities can be cavalier. And they may believe absolutely every word they say. And that's fine. That's fine. But when you want to suck other people into your headspace, be damn well sure that you're not going to cause more problems than you solve, right? This is why I never speak for my community. I only speak for me. This is why when people ask me to speculate on things, I pause and oftentimes say, no, I won't. Or if I do speculate, I will say, this is speculation, just like I did earlier tonight, because I refuse to walk the plank. It's not healthy for anyone. So you're not gullible. You just want to know. You just want to know about space, and space is it's so big and vast, and so many possibilities, that it's so easy to get sucked in. So don't be hard, don't be difficult, don't do that to yourself. I'm thrilled that you want to know more about space. I just don't want you to feel overwhelmed by it, and that it's evil, and that it's, this oppressive thing that's going to come and kill us all. It really isn't. CERN has over 40,000 locations. I have no idea what that means. That's crazy. I've noticed that major solar storms don't happen when the moon is in between the sun and the earth during a new moon. That's interesting. That's an interesting idea. Sadly, yeah, that's an interesting idea. I have no idea what type of coupling there would be. The moon doesn't, what would be really interesting is at Jupiter, because its moons are so, they have their own magnetic fields. Our moon doesn't have a magnetic field, so how it might help, deflect, I don't know. Sadly, again, most of the stuff that we have with our Earth's magnetic shield, is that it stuff that comes in front ends up peeling back the Earth's magnetic field, and it actually kind of disconnects the magnetic field itself and peels it back like this to the tail. So it's like taking bangs. I've done this before, where I have bangs on my face, and it's like taking the bangs on my face and blowing them back and coupling in the back. And so the blown back bangs, all of the action now is happening at the back of my head, not in the front. So having the moon here when all the action is actually in the back, business in the front, party in the back. Yeah, the Earth has a mullet. How funny. No, but if there's so much activity going on the night side of Earth, I'm not really sure how the moon on the day side is going to make a difference. But that would be an interesting study. I'm not sure anyone's ever done a study like that where they looked at the proximity of the moon in physical, in its geometric, location around Earth, whether it's apogee or perigee, and coordinated that with solar storms. I really don't think that's ever been done. What an interesting idea. Huh. I don't know if there's enough solar storms that occur during periods like that, but there probably is if people are willing to go and piece together, because we do have records for, several hundred years. So it might be possible. Okay. Yeah. Oh, yeah. Earthquakes. Yeah, thanks, Jerry. That's another real snake pit. Geophysicists, to this day, can't, they still are trying to quantify the primary drivers of earthquakes. And until they're able to do that, we as a space weather field are going to have a very tough time trying to get any quantitative information about whether or not space weather has a tertiary or even lower level effect on the mechanics of tectonics or anything else. People have talked about piezoelectric effects in GICs, and could the electric and magnetic fields in there and the charge distribution, could that possibly stimulate or affect the stresses on the rock? You can see mechanisms as to how that could happen, but just like I said with the upper atmosphere, how do you measure it, right? And if you do measure it, how do you know that you're measuring that thing? Because, like I said, geophysicists can't even get a decent measure of the primary driver. So it's kind of like having a yardstick that says my unit of length is this long, and you're trying to measure an ant with it. And it's like, well, how long is it? Well, it's shorter than this. And you're like, okay, but how long is it? How much is it? Well, I don't know. It's shorter than this, because that's the length scales and the measurement scales that we're dealing with, because geophysics is still having such a tough time trying to get their measurements more precise and their predictions more precise. So that's going to be a field that's going to stay into the fringe science for quite some time yet. Yeah, sadly. I mean, I think a space physicist would end up getting possibly a Nobel Prize if they could crack that nut and say yes and link inexorably link absolutely unambiguously link earthquakes with space weather. That would be great. Our field would suddenly have a lot more money. That'd be wonderful, but it's going to be a while before that we're able even to address that question in a quantitative way, let alone get funding to study it. So, okay. All right, guys, any other questions? We've been on for a long time, so I probably won't go over all of the details of my forecast, the specifics, but I will just put up for a second, just for those who've hung out with me this long. Whoops, I don't want to put that one up. I want to put up the other ones. I will show you some fun stuff here real fast. Wait, not that one. This one. I moved my phone. All right, there you go. Okay, so what you're looking at, this is how you know the different solar storms. So I'll just show you 3 solar storms super fast. This was the first one on the 27th. This mess is actually the signature of the solar storm as it launched. This thing is what we call a base difference image. And it's basically doing differences between 2 different successive images. So if there's no change, it stays gray. And if there is a change, it either goes white or black, okay, depending upon whether there's something now that's brighter than it was, and that becomes white, or something that was bright becomes dim, that goes black. So when you see these big bubbles of either light or dark, that lets you know something has changed since the last, since the beginning of the sequence. Okay, that's what a base difference image does. So you can see this kind of light, fuzzy kind of mess, right? Now I'm going to show you the movie of it. So this is kind of when it starts, and I'll just play it, I'll step out of the way. You see how this thing kind of develops over time? It'll play again. See how that develops over time? This is how we know. This is the scar that was left when that first solar storm launched, that we had that very, very fuzzy halo. That was the solar storm that caused, that was that first solar storm that hit us yesterday, okay? That was this, and you can kind of see the yellow arrows that I've got kind of highlighting the edges, right? This is region 3654. Yeah, this was that region there. And then you notice that there was this kind of, notice that there's like this structure here. This is part of a filament channel. And this is part of the thing that started erupting. This is part of what I think is what's causing these solar storms to have bigger, stronger magnetic fields. We actually have a coronal hole in this region in here, but there's this filament channel that's right between region 3654 and the coronal hole that lights up. And it lit up a little bit here, but I think most of it was from this region. It's kind of hard to tell. Now, if I switch to, okay, here's the second one. Let me walk it back a little. And I don't have as nice an imagery for this one, but notice in this one, so this is the second stealthy solar storm. This is the one that caused the G3 level event. Look at this here, this whole thing, okay? So this is, once again, region 3654. It continues to rotate to the west limb. This is the filament channel, okay? And it looks okay here, and you see it kind of lighting up here, but watch it light up this way. Watch it in here as I play. I'm going to stand on this side. So watch this region in here light up, okay? Can you see? Do you see this channel? Look at this channel, how you can see both sides of it, right? Something's going, letting go right here. I think this might be the thing magnetically, what had let go. And that's what gave us this very pretty structure, very strong magnetic field structure, okay? And now for the final thing, you can see this is the same section of the sun. I've actually done it, made it a little bit longer. And now this version of the sun, this one actually rotates. So you're actually seeing the sun rotate along with the same kind of difference imaging, okay? Unlike these images were what we call derotated, okay? This still has the sun rotating, and it's just a different way of looking at it. But now you're going to see more stuff on the limb being evacuated, and this thing lights up even more. Right here, okay? So this is what I think is possibly the third storm, because this happened a little bit later than even this did. So I think there's a third one that's on its way, but I'm not sure. We also have some fast solar wind, and it takes this kind of imagery to be able to spot these storms. And this kind of imagery is not stuff that is typically done in operations. So a lot of people don't use base difference imaging, and I credit Nariaki Nita, who is a team member of the AIA instrument on SDO, who works at Lockheed Martin. He's the one that really kind of, I don't want to say he didn't pioneer this technique, but he used it for space weather forecasting, I think, before really a lot of people did. And he turned me on to this methodology, and he does it even better than anyone I've ever seen. He has a very special technique that he uses. And yet these base difference images really can show you the extent of these stealthy solar storms when they launch, when otherwise you'd be basically blind. Remember when I showed them to you as they launched off the disk? You couldn't see them at all. And now they don't stand out like a sore thumb, but they stand out more than they would have, especially when you watch them grow, or when you watch them from nothing to something, right? I'll even back up here so you can see this one derotated. It's probably easier to see derotated than rotated, right? So look at that. Can't you see? Look how much of this structure lights up. You would never see this on just raw imagery, what we call the intensity images. So this was the technique that I used to get these solar disk imageries and to find where the solar source regions are. And it tells me that it's something that I definitely need to be training at Millersville a lot more than I do. So this has been very instructive for me over the past week to talk with a lot of the NASA M2M and CCMC and 557th people to know, okay, this kind of training is something we should be doing. So, okay. You're very welcome, Angel. Thank you for being real within your heart. Yeah, you know, I don't think I would have taken such a big detour tonight, except I just saw these questions coming up over and over and over again in the chat, and it was just like, okay, this is just getting to be too much, you know. Because what's going to happen is if we don't head this stuff off at the pass, when we get our first G5, which we will, you know, could we get a G5 in this solar cycle? Absolutely. Will we get another G4 in this cycle? Absolutely we will. I don't doubt it for a minute. With the types of structures that I've seen coming off of the sun, I do not doubt it for a minute that we'll get another G4. And people are going to start going, ooh, we've never seen storms this strong. It must be our Earth. And it's like, no, it's not. It's our sun. It's our sun. It's okay, and it's normal. So that's why I kind of wanted to head this off at the pass as much as I can before it blows out of proportion. So now all of you know, and now you can tell everybody else that it's okay. This is natural for our sun, and all you have to do is go back to, you know, the 50s, 60s, 70s, 80s, and 90s, and you will see structures and you will see storms that are this strong. So it's not our Earth's field. Okay, anyway. Tamitha says, Joseph, you've asked, unless you are in space weather emergency, I know we are all good. Right. Luckily, I'm training emergency responders, so hopefully they can, you know, they'll be able to use space weather and let the Red Cross know when their sat phones aren't working because of big radio bursts. As a matter of fact, I need to go back and check to see if any of that big X flare had a strong radio burst in it. It might. It'll be interesting to take a look. I didn't find any video. Are you talking to me, Dustin? I didn't find any videos. Was that just a do your own research deal? Any videos on what? So if that question is to me. Let's see. Venting is good. Time to wrap. Yep. No problem, Jerry. Okay, guys. Yeah, thanks so much for staying online with me all this time. And hopefully this was useful to you. And I will, you know, I'll be around. And for those of you on Patreon who want to ask me more questions, I will also be in the community chat on and off this evening, and of course a lot over the next couple days as we continue watching these potential solar storms roll in. Let's see, let's take another look at this data and see if it is indeed climbing. Yeah, see, this is back to climbing again. Oops, oh, let me change real fast, I'll show you. EPAM is climbing again, guys. So, see this? So that low energy particle stuff, it's still climbing. So something's still out there, something's coming. That's my guess. Something is coming. Otherwise, you just wouldn't see this particle flux continue to climb. You would see it really begin to die down and dry down, and see even this level is flattening. It's flattening out. So we'll see that. We'll start seeing that in the other levels too. So something is coming. Now, whether it hits us or not, I don't know. But something is still out there, and we will be seeing it probably within the next 24 hours. Okay? So keep your eyes on the skies and do not be afraid. Everything is okay, I promise. Okay, guys. Have a good night.